Hello dear students, welcome back to BYJU'S Exam Prep. Now under this GATE Rankers Monsoon series, the topic which I am coming up with is Discrete Mathematics, and in that the counting technique. The counting techniques are the most important, for computer science student. Not only for discrete mathematics, it is useful in your algorithms, data structures, operating system, everywhere. The basic idea of discrete mathematics is counting discretized objects, and today's topic is basic counting techniques. So let us start the topic, my dear friends. And before starting, this is about me, myself Sridhar Dhulipala. I am having 20 plus years of teaching experience, and my qualifications are given here, and achievements, everything. Now under BYJU'S Exam Prep, this is my regular statement for all of you. This is a promotion. Under BYJU'S Exam Prep app, under the category Learn with Video Lessons, you can find all these videos recorded by me. The subjects: Discrete Mathematics, Algorithms, Engineering Mathematics, C Programming and Data Structures. You can go through these videos. Those who purchase can access all the videos. Even otherwise, you can go through some of these videos, my dear friends. So now let us start with the story of today. And this is very, very basic and very, very important, my dear friends. The counting technique is heart of discrete mathematics as well as computer science students. Now look at this simple example. Institute A offers 3 courses. So there are 3 institutes. One is A, the other one is B, and the other one is C. So they are offering courses. Generally, after learning regular college courses, you may need to learn some additional courses which are very, very hot in the market. So you generally go for some institutes and they offer the instrument courses. Like A is offering 3 courses, B is offering 4 courses, and C is offering 2 courses. Sir, I am from EC branch. Yes, it is helpful even for your aptitude part. These are general techniques. For computer science people, this is very, very important. For other branch people, you can expect these questions in your aptitude also. So these are general counting ideas. They'll help you in understanding aptitude questions, or they'll improve your aptitude also. It is good for everyone, sir. It is useful for everyone. Of course, in the syllabus it is there for CS students in discrete mathematics. For other branch students, under aptitude you can get it. Not only that, it will improve your analytical skills. Good topic. Now the simple question is, how many ways we can select a course? Can you give me the answer for this, sir? Can you give me the answer for this? How many ways we can select a course? Very good, Tushar. Good evening, Tushar. Very good evening. Very, very good evening. Yeah. What about answer? My audio, video, everything is fine? Yeah. See, my dear friends, if you want to select a course, you can select any one of the course from Institute A, or you can select any one of the course from Institute B, or you can select any one of the course from Institute C. So it is 3 plus 4, 7 plus 2, 9. Am I clear? See, here we are assuming that there is nothing common between these courses. See, generally this rule which I applied is called sum rule or addition principle. You need to understand the rule properly. Here, when I am saying 3, 4, 2, I am assuming that there is nothing common. They are all distinct courses. Suppose here there is some data science course, and here also there is some data science course. The student will have 9 choices, no? Number of ways you can select a course, because there is some commonality. The number of ways you can select a course is less than that. See, how you solve that is different story. We will discuss that in your inclusion exclusion principle. Here I want you to understand these principles properly. See, the problem with most of the student is they just take a rule as granted. We need to understand the rules under what conditions. That is very, very important, my dear friends. So the rule which we applied here is what is known as sum rule, or you can also call it as addition principle, my dear friends. Okay, it's not working today. Right. Now this is simple, detailed form of this sum rule or addition principle. Suppose there is an event which can occur in m ways, another event which can occur in n ways. The question is number of ways either A or B can happen. See, number of ways A or B can happen. Here both are happening at a time. There may be some commonality. Okay, number of ways A or B can happen is m plus n. When you write this rule, we need to understand, we are assuming that the events are disjoint events. The events are disjoint events. This is important point to be noted, my dear friends. Am I clear? Like that. So, if event A can happen in m ways, B can happen in n ways, then A or B, they are happening at a time simultaneously, and number of ways either A or B can happen is given by m plus n, with the assumption that there is nothing common between the events. No courses are common between them. Am I clear? So that is the sum rule or addition principle. Let us take this problem. This is another problem. Suppose there are cities are there, sir, city A, city B and city C. This is a very common regular question. From A to B there are 4 routes. From A to B 1, 2, 3, 4 routes are there. And from B to C there are, 3 routes from A to B. Oh, I given one extra, no problem, I'll give you this. And from B to C, how many routes are there? 4 routes are there. 1, 2, 3, 4. The question is very simple. How many ways we can reach from city A to B via C? A to B via C. Number of routes. We need to find number of routes from A to B via C. So, I think I am starting with a very simple problems. You can answer. Hi Sahil Vekhande. Very good evening. Welcome to the class. There is slight delay, my dear friends, in YouTube because after I say, okay, it may take around 10 seconds to reach you, and again you say that reach me after 10 seconds. So there is slight delay, my dear friend. Hi. Yeah. Anyone answering? So the idea is very simple, sir. For each route from A to B, there are 4 routes from B to C. That is, for one route from A to B, there are 4 routes from B to C. So for 3 routes, how many routes are there? It is simple like your chocolate problem. If one chocolate is 4 rupees, 3 chocolates, how much? The answer is exactly same as that. See, for one route we have 4 routes, then for 3 routes, how many routes will be there? 3 into 4, that is 12 routes. Now again here also we need to understand this carefully. Now suppose if I put a condition that if you take the first route, or let me do this. Suppose if I say that if you take the first route, you are not allowed to take 4th route. Can you have, very good, not 3 plus 4, 3 into 4 dear Sahil, it is 3 into 4, 12. If I say this condition, you will have 12 routes? No, right? Because for first route there are only 3 choices, whereas for second and third there are 4 choices. So the answer becomes 3 plus 4 plus 4, because for first route 3 routes are there, second and third 4 routes are there. So the answer becomes 11. So here when you say 3 into 4 is equal to 12, again there is a condition we applied. The number of the choice of the second route is independent of choice of first route. That is, these routes from A to B and B to C are independent of each other. So when you say the 12 answer, the point to be noted is the first choice and the second choice are independent of each other. And this rule which we applied is what is known as product rule. What is it called? Product rule. Suppose an event A can occur in m ways, another event B can happen in n ways. See, you can say event, you can say task, anything. Okay, or there are m ways of selecting one thing and n ways of selecting other thing. Then number of ways A followed by B can happen. Number of ways A followed by B can happen. And when you say this particular rule, we need to understand this point that they are independent. See, those who want to understand probability, they need to understand this concept very clear here itself. Okay, people do entire probability without understanding this basic idea. Am I clear? These are the very, very minute details one need to understand. Okay, basic concepts. Independent events. See, independent is simple. Happening of one event does not affect happening of the other. Here the events are not happening at a time. They are happening one followed by the other. The events are happening one followed by the other. Am I clear? So the number of ways A followed by B can happen if they are independent is given by M into N, my dear friends. Is the idea clear? Good. Now let us take this question. Same question, first question, but there is a small variation in the question. Please read it carefully and answer this question. A can offer 3 courses, B is offering 4 courses, C is offering 2 courses. Please answer this question and please try to identify the difference between first question and this question. See, I am trying to give you very, very minute details, my dear friends. These are very, very important. Okay? What is the answer for this? Okay. See, here he is asking number of ways to select a course from each institute. It is not number of ways you can select a course. Number of ways we can select course from each institute. That is, from institute A, how many ways you can select a course? 3 ways. For each of these 3 ways, we can select a course from institute B in 4 ways. For each of these, we can select a course from institute C in 2 ways. So the number of ways is given by 3 into 4 into 2. So the answer is 3 into 4, 12, 12 2's 24, my dear friends. Yes, wonderful, perfect, perfect. That's it. Here it's not just selecting, adding them. You can select a course, perfect Sahil, perfect. You can select a course in 24 ways. Is the idea clear? Because there is no condition, all the courses are different. See, this is what he is mentioning. There is nothing dependent on. If you take this course, you cannot take this course, or to take this course, this is the prerequisite. If such conditions are given, then this will not be the answer. So, when you apply this product rule, what you need to understand, it is the basic rule when all the events or all the tasks are independent of each other. Simply multiply them, because one followed by the other can happen in how many ways this can happen? Into how many ways this can happen. Multiply, you will get the answer. Perfect answer, sir. Perfect. Now, look at this. A building contains 10 floors and each floor has 20 rooms. Then the number of rooms in the building. How many rooms are there in the building? Please answer this question. So, I will tell you how to solve this problem using sum rule, how to solve this problem using product rule also. Okay, see here today's class is basic counting technique. So I restrict myself to the basic ideas of counting techniques. See, my dear friends, see, the answers are very simple, sir. I am not very much interested in the answers. I am interested in the concept, the idea with which we solve this problem. That is important. Am I clear? Because without understanding sum rule, product rule, if you continue further, it will trouble you in later stages. Please understand that. Now look here, number of rows. See, my dear friends, 10 floors. Each floor is having 20 rooms. Each floor is having 20 rooms. Okay, suppose if you want to solve this problem using, okay, let me do this. Suppose if I want to solve this problem using sum rule. Same problem, number of rooms you want to calculate. See, you can select a room from first floor. First floor, how many ways you can select a room? Yeah, 200, correct Sahil. First floor you can select a room in, because each floor is having 20 rooms. Or you can select a room from second floor, or you can select a room from third floor. Like that, you can select a room from 10th floor. So the answer would be 20 plus 20 plus, because you can select either from first floor or second floor or third floor or fourth floor or 10th floor. So the answer would be 200, my dear friends. So this is how we solve this problem using sum rule. What about product rule? See, if you want to solve this problem using product rule, first choice and second choice. See, first you have to select a floor. Followed by that, you have to select a room. First choice and second choice. See, the first choice would be select a floor. The second choice would be select a room. Because after selecting a floor, in that you select the room, that also will do the same work, my dear friends. So what is the answer for this? Select a floor. How many ways you can select a floor? Because there are total 10 floors. You can select a floor in 10 ways. For each of these 10, how many ways you can select a room? Because in each floor, how many rooms are there? 20 rooms are there. So the answer would be 200. So the same problem can be solved using sum rule or product rule. It depends on the nature of the problem, my dear friends. Am I clear? So the answer is perfect, Shahil. That is correct answer. Good. Now let us see one more problem. Suppose a bookshelf contains 3 algorithm books, 5 discrete mathematics books. So algo books are how many? 3. Discrete mathematics 5 books and data structuring books 2 are there. Question is number of ways we can select a course or number of ways you can select a book. Number of ways a book can be selected. So the question is how many ways you can select, because he is just asking you to select a book but he is not mentioning which book. He is just asking you to select a book. So you can select any of these algorithm books or any of this discrete mathematics book or any of this data structuring books. Of course, there is nothing common between them, right? Am I clear? There may be some books which are both data structuring and algorithms. In such case, this number will reduce. That if you want to solve, you have to see inclusion exclusion principle. So what is the answer for this? 8 plus 2, the answer would be 10 for this. So what is the answer for this? 10 is the answer. Now suppose if I ask the same question like this. How many ways we can select same information? Suppose a bookshelf contains 3 algorithms, 5 discrete and 2 data structure. How many ways can we select one book of each type? One book of each type. Yeah. See, here it is 10. Are you answering next question, Sahil? Are you answering next question? See, here algo we have 3 books. Discrete mathematics we have 5 books. Data structure we have 2 books. The question is number of ways we can select one book of each course. One book of each course. One book of each. So we have to select an algorithm book. How many ways you can select an algorithm book? 3 ways. For each of these 3 ways, how many ways you can select discrete mathematics book? Because there are 5 choices, there are 5 ways you can select discrete mathematics books. And for each of these 15 ways, how many ways you can select data structures book? 2 ways. Because there are 2 data structures books. So the answer would be 30, my dear friends. See, if your answer is for this question, example 6 it is 30, but example 5 it is 10, my dear friends. So read the question carefully. Now this is the question. If 2 distinguishable dice are rolled, then the number of ways they can fall. See, this is generally, sir, actually this term may not be used, but by default we assume that the dice are distinguishable. What do you mean by distinguishable dice, sir? See, one die may be of some greenish color, the other one may be of blue color. So this is what we call it as distinguishable dice. See, each die is having how many choices, sir? First die is having 6 choices. It can be 1, it can be 2, 3, 4, 5 or 6 on greenish die, followed by it can be 1, 2, 3, 4 or 5 or 6 on bluish die. See, for each of these choices, there are 6 choices of second die. So for 6 choices, how many choices will be there? So the answer would be 36. See, my dear friend, by default when you say dice are rolled, we assume that they are distinguishable dice. There are distinguishable dice. Very good, Sahil. There are distinguishable, means they have different color or different shape or different size. That is what you mean by distinguishable. You can identify them as, okay, this is different and this is different. See, it's like, I'll just show you. This one followed by this this one followed by this one followed by this, that is 1 on greenish dye and 3 on blue dye, 1 on green dye and 4 on blue dye, like that. So total how many choices will be there? For each choice of the first dye, that is each outcome on the first dye, there are 6 outcomes on the second dye. So for 6 outcomes on the first dye, total how many outcomes will be there? 6 into 6, 36. Is the idea clear? So that is the answer, my dear friend, nothing more than that. See, these are very, very minute, simple problems, my dear friends, I want you to understand. Now let us take one programming question. Of course, these are very old, okay, program questions from directly from, Rosen book I taken this example. Consider the following program segment where I, J, K are integer variables. Okay. Now here it is a Pascal code, my dear friends. You can replace this code with your C code, where the generally the index generally varies from that. The loop variables vary from 0 to some other value. But like Fortran and old programming languages, index starts from 1 also. You need to understand this. Now look here. The question is, how many times the print statement executed in this program segment? This is the question. See, my dear friends, for every value of I, the inner loop varies how many times? For every I, that is for every I, inner loop varies how many times? 1 to 10 means 10 times it varies. Correct or not? Means every time inner loop varies, we enter the loop and the print statement executed. That is, for every value of I, print statement is executed 10 times. This is 10 times print executed. Correct or not? Now, how many times I is varying? Because for one time I varies, J varies 10 times. For 20 times I is varying, total how many print statements executed? So it is also straightforward question. It's a simple product rule only. Am I clear? See, even if you find a simple problem like I is equal to 1, I less than or equal to n, I plus plus. This is regular question which they ask. Time complexity questions. For j is equal to 1, j less than or equal to n, j plus plus. Number of times this loop iterates. Okay, number of times you enter and print the whatever statement is there that is executed. See, I is varying how many times, sir? I is varying n times. For each time I varies, that is for each value of I, j varies n times. So for n times I varies, total how many iterations happens? N into n, n square. This is how we find this, my dear friend. Wonderful. 200 is perfect answer, my dear friend. Sahil. Correct. Good. Same story, my dear friends. Of course, you can extend this. Like, this is what we call it as nested loop, my dear friends. If you want, you can extend this to 3 loops, 4 loops. You can next to any level, my dear friends. Am I clear? So the idea is perfect. Yeah, that way also you can do 10. Sahil, perfect. That is how we can see it as a sum rule. Okay, now you can see it as product rule also. Wonderful, perfect. See, when you see basic level problems properly, you understand these details, my dear friends. What generally I find is people are interested in advanced topics. They always ignore the basic level. See, in GATE, you get such questions also. Please remember, every problem is possible. They don't only ask you advanced level questions. They'll ask you, it is, comprehensive understanding of your undergraduate subjects. So question can be asked from anywhere. You don't say only last chapter 3 questions I want to solve. You are out of the GATE, my dear friends. You cannot enter the GATE. Please remember. Okay. Now look here. You want to create 3-letter word. Now, whenever the problems are given, one point we need to understand. There are some basic assumptions we make. Generally, letters means now I say that I want to use, because my mother tongue is Telugu, I want to use Telugu mother tongue or Telugu words. Someone says, no, I want to use Hindi. Someone says, okay, Kannada words, Malayalam. Like that, everyone keep on saying their mother tongue letters. That is generally, it complicates business. And for every problem, giving very, very minute details also in the statement is very, very difficult, sir. So we make some certain assumptions because the language of examination is English. We assume that the letter, whenever is mentioned, we assume that English letters. Am I clear? English alphabets. Now again, English alphabets means Again you get doubts whether lowercase or uppercase. Unless or otherwise it is mentioned, we just assume that only one case, maybe lowercase or maybe uppercase only we assume it. Am I clear? We don't take lower plus upper is equal to 52, my dear friends. So by default we take it as 26 letters only. Please remember this point. These are the simple things one need to understand. Basic assumptions we call it. Am I clear? Especially whenever you're doing counting technique, these basic assumptions we need to understand. Otherwise in the problem it has to be explicitly mentioned. Okay. Now you want to create a 3-letter word. How many ways you can fill the first position? This is 3-letter, no? So first position can be filled in how many ways? Because there are totally 26 letters are there. So 26 choices we are having for first letter. Now for each of these choices, how many ways? Yeah, if it is not mentioned, by default repetitions allowed, sir. By default repetitions allowed. Default is always repetitions allowed. And again, it may depend sometimes on the type of problems. See, sometimes, you blindly take repetitions allowed. Suppose if I am talking about, arrangement of people. You say, sir, repetition is not mentioned, so by default repetitions. How can you repeat human beings, my dear friends? So, that situation, even though it is not mentioned, we understand from the context that repetition is not allowed. Am I clear? So, these are the basic assumptions, that's what I am saying. In such cases, we assume that repetitions are allowed. Am I clear? That is the point to be noted. Got it? So, for each of the 26 choices, at the first place, how many choices we are having at the second place, sir? Because repetitions are allowed by default 26 ways. How many ways the third position can be filled? 26 ways. Wonderful. So the answer would be 26. Now I am solving the very simple binary question, sir. Please try to follow. Now look here. A license plate or license, whatever you call it, consists of 3 uppercase English letters. This time you see he is mentioning it in a more detailed manner. 3 uppercase English letters, okay, uppercase English letters followed by 2 digits. So this is the format of a license plate or license, my dear friends, of a particular nation or a country or a state. How many different licenses or license plates are possible? Wonderful, Manish Gupta. Great, good answer, perfect. Now please answer, sir. See, if you are answering, I'll wait, otherwise I'll continue, sir, because I do not know. See, teaching in YouTube is like teaching on a open platform. So whether people are regularly answering, in a classroom we can expect answers regularly, but here it's quite difficult for me to understand whether you are answering or not. If you are answering, I'll wait, otherwise I'll continue. Am I clear? I don't want to disturb people, sir. But these ideas which I am discussing, very basic ideas, sir, very basic level problems, but they are very important. The way we handle them is important, not just solutions, sir. Solution everyone will do it. I am not at all worried about it. Especially for computer science students, the details are very important. Maybe for other branch people, the details may not be that important, but for CS students, the details which I am telling are very important. Okay, wonderful. Because uppercase 26 choices, because repetition is not mentioned, by default repetition is allowed. 26. Digits, first digit. Now again some people get doubt, sir, can first digit be 0? See, it's a license plate, there is nothing mentioned. Suppose if you are generally saying like 3-digit number, in such case first digit we cannot put 0, because in 3-digit number 0 cannot be first digit. But here it's a license plate, he says 2 digits, where the choices for digits are 10. We know that 10 and 10. So the answer would be 26 cube into 10 square, my dear friends. Perfect answer, perfect. Same question. License plates, here this time I written clearly. License plates consisting of 3 uppercase letters followed by 3 digits containing no letter or digit twice. That is, letters and digits are not repeated, not allowed. Where repetitions are not allowed. Am I clear? Wonderful. So here also uppercase 3 followed by 3 digits. It's not 2, 3 digits. What should be the answer? I think you can answer this very simple question. Wonderful, Sahil. So first 26. Now whatever letter is used cannot be used again here. 25 choices. These two cannot be used here. 24 choices. Done. Now for digits, 10 choices followed by 9 choices followed by 8 choices. See, these are the very basic level problems, sir. We need to understand. See, what I want you to understand in these problems is, first problem, no condition. Now I start imposing conditions. Counting is all about this. Generally, the problem without conditions is very simple. Problem without condition is very simple. See, the same problem can be asked in probability. How many? What is the probability of selecting a license plate in which repetitions are not allowed? What is the probability of selecting a license plate of this type in which repetitions are not allowed? Good. So the same problem can be asked as a probability problem. See, normally how many license plates are possible? 26 cube into 10 cube. That is total possibility, no condition. Total is probability of a event is what, sir? Favorable for event by total possibilities. See, the total possibility is without any condition. But for this problem, what is the condition I am imposing? Repetitions are not allowed is the condition I am imposing. So, numerator would become 26, 25, 24 into 10, 9, 8. That is, out of all possible license plates, I want to select a license plate, okay, in which repetitions are not allowed. So, that would be the answer, my dear friends. So, same stories will be given as a probability problem. See, probability, there are two things. One is total, all possibilities, favorable, with conditions or with constraints. So, these are kind of constraints here, my dear friends. Am I clear? From total possible license plates, what is the possibility that the selected license plate is without repetition of digits? That is the question. Are you able to follow that question, sir? All of you able to follow? Like that. So, the same story can be extended to probability also. Am I clear? The basic level probability is all like that. Now, next one. Now, look here. Can be made using either, see, the story is very interesting. How many license plates can be made using either 2 or 3 uppercase English letters followed by either 2 or 3 digits? Please answer this question, sir. Very interesting problem. Please answer this. Yeah, good. Please answer, sir. So here the story is, it should contain 2 or 3 uppercase English letters followed by 2 or 3 digits. Okay. So 2 uppercase or 3 uppercase letters followed by 2 digit or 3 digit number. Now look here, sir. 2 uppercase means what? Because previously we solved, now we should solve it separately, directly. 2 uppercases means this is 26 and this is 26. So this can be done in 26 square ways or 3 uppercase letters, that is 26 cube followed by 2 digits, that is 10 square or 10 cube, 3 digits. And that is the answer, my dear friends. Or some people, what they do, they expand this statement. 2 or 3 followed by 2 or 3, no? So 2 letters or 2 uppercases followed by 2 or 3 digits, or 3 uppercases followed by 2 or 3 digits. Again they expand it further. 2 uppercases followed by 2 digits, or 2 uppercases followed by 3 digits, or 3 uppercases followed by 2 digits, or 3 uppercases followed by 3 digits. So this much expansion they do it and they solve it. Now this one is clear now. 26 square into 10 square plus 26 square into 10 cube plus 26 cube into 10 square plus 26 cube into 10 cube. Actually, if you expand it, you will get this answer, my dear friends. This is how you look at the problem. It matters. Okay. See, in counting, it's all about understanding the constraint, applying the constraint, my dear friends. If you can able to do this, it also helps you in basic level probability very, very easily. And you will never feel probability is difficult. Am I clear? See, generally, why people feel probability is difficult? Because they don't understand counting. Or some people feel counting is easy but probability is difficult. How is it possible, my dear friend? Basic level probability should be easy if counting is simple. Am I clear? Because the same story there we are applying. Am I clear? Now look at this example. Okay, it was a question taken from some old book. Okay, I just modified. Okay, to get nativity. Raju works as computer operator. Those who study your operating system can understand some of the statement properly. Even otherwise we can understand, I'll explain. Suppose that 8 computer programs have been submitted earlier that day for batch processing. See, batch processing, what happens? The programs are submitted to the system one after the other. Okay, single batch processing, there are multi-batch processing will be there. So we are assuming that single batch processing. In how many ways can Raju order the processing of these programs, assuming that there is no restriction? So 8 programs are there. I am having some processor where I can only process one program at a time. So how many ways this can be done? See, my dear friends, there are totally 8 programs. There are totally 8 programs. 1, 2, 3, 4, 5, 6, 7 and 8. Now I can process one program at a time. So first, which program I can process? I can process any of the 8. That is, I am having 8 choices for the first one. That is, I can select any of the 8 programs for processing. After that, this program is gone. Now I am having only 7 ones. So for second batch or for second processing, I am having only 7 choices. And for the third one, how many choices I am having? 6 choices. Next one I am having 5 choices. Next one I am having 4 choices. Next 3, next 2 and finally 1. That is totally he can process those programs in 8 factorial ways, my dear friends. Am I clear? Suppose no restriction are there, he can happily do this in 8 factorial ways. That many choices he is having. He is free to do anything. But if I put a restriction, something like this. What is the restriction I put? If he considers 3 of the programs higher in priority than the other 5, and want to process those 3 first. Suppose he assumed that there are 3 programs in that which are having higher priority and he knows what are the programs. If he does not know, again that is another difficult question, because priority is known means you know what are those programs. Okay. So there are 3 programs for which priority is known. So he want to process these programs first before other 5. How many ways this can be done? Can anyone answer this, please? So here we are having total 8 programs he need to process. 1, 2, 3, 4, 5, 6, 7, 8. But the first 3 programs which need to be processed are the fellows which are having higher priority. So first you have to process the 3 programs. After that the 5 programs to be processed. How many ways these 3 programs? Because wonderful Sahil. These 3 programs can be processed in 3 factorial ways. followed by other 5 programs which can be processed in 5 factorial ways. 3 factorial into 5 factorial. See, the condition is that. So suppose the same problem can be asked as a probability. What is the probability that he process 3 followed by 5? So what will be the answer? 3 factorial into 5 factorial by 8 factorial. This is called constrained problem, whereas this is without constraints. So probability, the same thing will happen. Events are with conditions, whereas the sample space or the total number of possibilities would be without that constraints. That we need to understand, my dear friends. Okay? This is interesting. So please answer this question. Now we have series of 4-5 problems. Follow all of them, and these are gate questions. Some of these are gate questions also. Okay, not I may change the numbers, sir. This may be 3, there they may be given 4. I changed the numbers, but the story is same. Okay, so let us take this problem. This is a gate. I am going to answer one gate questions now. Let us see, and I want you to answer this, sir. Please answer the questions. Then I will explain one after the other. Okay. Yeah. How many 3-digit numbers are there? Wonderful. So here we are having 3 positions to be filled. This position, because starting we cannot start with 0, because 3-digit number cannot start with 0. That condition is not mentioned, but we understand. So 9 choices. And now is it with repetitions or without repetition? By default it is with repetitions, because in 3-digit numbers we can have 888 like RRR. Am I clear? Now here how many choices we are having? 10 choices. Here how many choices we are having? 10 choices. So 900 is the answer. Perfect, perfect. How many of them are even? Next one, how many of them are even? See, I am going to take you to a problem which is gate question, and we answer that. But for that you need to understand all this properly, then that gate question will be easier. I will give you different ways of solving the same problem. See, normally we are only interested in solutions, but here in computer science we are interested in detailing, because we need to teach this to someone who is dumb. Computer. Yeah, 450, perfect sir. Akash Bandari, perfect. So we want 3-digit even numbers. See, even means it should end with either 0, 2, 4, 6, 8. So 5 choices we are having. Now here 0 is not allowed, 9 choices, and here 10 choices. So the answer would be 450. But there is one more idea, because an idea can change your life. The idea is, whenever you are having consecutive numbers, starting with an odd number and ending in an even number. Because when you are taking 3-digit numbers, 3-digit first number is 100 and last number is 999. We are starting with even and ending with odd number. And we already seen total is equal to, how many total number are there in the previous problem? We already seen 900 are total. So we are having consecutive numbers, consecutive integers, starting from even and ending with odd or vice versa. Half of them will be even and half of them will be odd. Am I clear? So in this, half of them, that is in the total, what is the total, sir? 900. If I want how many are even, half of them are even and half of them are odd. So odd would be how many? 450 only, because half of them are even means half of them are odd. And the same question, of course, how many are odd numbers, I will directly solve it. But here I want to introduce one more counting technique. See here, with the same very basic examples, I am introducing the counting ideas. I introduce some rule, but in some rule, most of the people misunderstand. Some rule for every problem. No, some rule is applicable when the events are disjoint, nothing common between them. There is a big secret. Then product rule I introduce. Again for product rule, the basic product rule you write like m into n or m into n into r, whatever it is. There the events are independent. These are the basic simple concepts one should understand. Here also with this simple example I am introducing one more concept, that is called indirect counting. And one of the greatest discovery we can say, indirectly counting. Of course here it's very simple, sir, but the idea is important. Instead of solving the problem directly, we are solving indirectly. You want to know how many odd fellows are there, because either their numbers will be either even or odd. From total you remove how many are even, you get odd numbers. This indirect counting is one of the counting techniques. This is also called a counting technique. For some problems it will do wonders. We should understand it. So sometimes what happens, a problem will be given, you want to solve it, it's stuck somewhere. People want to solve it straightforward way, it will take years of the time. Am I clear? Maybe years or lifetime achievement it may become. But if you do indirectly, it may solve the problem very quickly. Let us see one such problem in the later stage. Total how many? 900. Even how many are there? 450. So the answer would be 450. So this is one important counting technique called indirect counting. Now, how many 3-digit numbers are there which have no repeated digits? Again, simple problem. This you can answer, sir. Easy question. Very simple question for all of you. And tomorrow's class, we discuss one more interesting counting technique which is called pigeonhole principle. And for theory of computation, okay, that is one. Pumping lemma is based on that. Like that. So there are so many direct applications are there for these principles. Am I clear? See, generally also that pigeonhole principle, whenever there is a congestion, okay, that kind of situations also it can help you, sir. Okay, that is one more interesting technique. Tomorrow we discuss pigeonhole principle. Am I clear? So who is answering this? Yeah. So here repeated digits, no repeated digits, first we can fill in, because first position cannot be 0, 9 choices, but in the second position 0 can come. So other than 0, how many more there? Whatever digit is filled, that is ruled out, because repetitions are not allowed. For example, if it is 5, suppose if it is 5, 5 is ruled out, but 0 is allowed. So 0 plus remaining 8. That is how many choices we are having for next position? 9 choices. Next, 8 choices. 9 into 9 into 8. If you have calculator, you please answer. 81 into 8. 8 ones 8. 64, 6, 4, 8 is the answer. Am I clear? See, practicing means instead of 3, you take 10 digit number. Practice it. 7 digit number, practice it. 6 digit number, practice it. After solving it, practicing is change this and solve it. You get good practice, my dear friends. You don't have to refer any books also. Please answer this question. This says similar to that of a GATE question. A GATE question was asked in the similar format. Okay? Please answer this. It takes time, I know that. So take your own time, not till tomorrow. This is the most important question, my dear friends. 330 is not in the options, Akash Bandari. 320, yep, option A, very good. So he says 320. Anyone else? Wonderful. But let us see how to solve this problem. One second. Okay. Now let us see how to solve this problem. Now look here, sir. He is asking how many 3-digit even numbers are there which have all the 3 digits distinct. Same as the previous problem, but we want even flows. See, there is a very important twist in the story which we need to understand. See, when you say even, it can end with a 0, 2 or 4. But the problem is, there are two situations here. Even only. Even means ending with 0, 2, 4. But when it is ending with 0 or when it is ending with 2, 4, the situations are not same. You need to understand this. And that is what the twist in this particular problem, my dear friends. Okay. See, my dear friends, suppose if it is ending in 0, this can be done in one way. 0 means one way. Because 0 is already filled here, for the first position 0 cannot come because 0 is already there taken, because digits cannot be repeated. So for this we have 9 choices, my dear friend. For first position 9 choices and second position will be having 8 choices. So if it happens, that is if it end with 0, 9 into 8, that is 72 choices we are having. 72 ways it can happen. But when it is ending with 2 or 4, there are 2 choices for this. Either 2 or 4, 2 choices. And if it is ending with 2, 4, we should restrict 0 here. 0 cannot come in the first position. Because 0, if it is taken in the first position, it cannot be 3-digit number. Am I clear? So 0 is restricted and whatever number is filled in the last position, that is restricted. So here we have only 8 choices. Here we have only 8 choices, my dear friends. Here we have, 0 to 4, why I written 0 to 4? 0 to 4, 6, 8. Sorry, I made a mistake. 0 to 4, 6, 8. 4 choices, sorry. 4 choices. 4 choices, sorry for that. I make a 4 choices. See, ending with 0 or ending with 2, 4, 6, 8. Ending with 0 and ending with 2, 4, 6, 8 are two different stories. Why? Because if it ends with 0, it cannot come in the first position. So that situation is completely different from ending with 2, 4, 6, 8. Here 4 choices are there. 4 choices. So one number is filled here and 0 is not allowed, 8 choices. Now here how many choices we are having? 7, but here 0 can come. So 7 plus 1, 8 choices. So how many ways this can happen, sir? 64 into 4. 25, 256. This can happen in 256 ways. So the answer for this problem would be 256 plus 72. That is 8, 12, 3. 328 is the answer, my dear friends. And this is one of the important GATE variant. I just changed the number, sir. Okay, you try this. Maybe full courses for each subject not completely freely available, sir, but some of those lectures you can watch in app. Okay, but I'll be coming up with some lectures here. See, completely free the recorded content because many people are involved. So some portion you can watch, my dear friend. Am I clear? Yeah, very good, Sahil. Okay, like that. So this idea we need to understand, my dear friends. So answer for this is 328. Or this is easier question than that. You solve this, then use indirect counting, you get answer much easier. This is alternate technique for the same problem. The alternate technique for the same problem, my dear friends. Okay. See, if you want to solve that problem easily, because 3-digit number in which which is odd and no repeated digits. Here we don't have two situations, we have only one situation. That is, it can end with 1, 3, 5, 7, 9. Because no 0 here. So the last position can be filled in 5 ways. 0 is not allowed. So 0 and last position, whatever is filled here, these two fellows are ruled out. 8 choices we have. And here 7 and 0 is allowed. So 8 choices. 8 into 8 into 5. Okay. 64 5s. How much, sir? 64 5s? I think 320. Someone answered this only. I think Akash answered this way. 320. This is, you know, what we call it as trap. Gate traps. Okay. In gate, they always do such traps, sir. They always put you in such traps so that you do mistakes. Am I clear? This is number of odd fellows. Now, if you want to know how many even are there, you can do indirect counting, my dear friends. You can do indirect counting. See, my dear friends, all my lectures, whether it is recorded or anywhere, I always start from very basics, my dear friends. I don't assume that student already know something and they are coming here, because I understand different situations. I always take, because I believe in that. Once you learn basics, your base is strong, your building can be very, very strong. That I believe it, sir. Am I clear? Yes, AB, perfect, perfect. That is answer. So if you want to do even from total, you can subtract odd. So total is what? We already know now, 648, I think, right? 648 minus 320, which gives you 328. So for odd, there is only one type of situation, but for even, ending with 0 and ending with 245, 2468 are different stories. That's why we have to consider in two different ways and solve the problem. If you have any doubts, please do ask me, sir. If you have any doubts, please do ask me. Okay? How many non-negative integers less than 10 power 5 are there? How many non-negative integers less than 10 power 5 are there? Next question. Okay, I think we already at the end of time. If more people are interested, I can continue. Otherwise, I will stop with these problems. Okay. Tomorrow's class we will discuss P-John-Hole principle. If you have any general doubts, you can ask me. Otherwise, I will solve it. See, I will give you a general logical way of solving it. Okay. Common sense way. Also, I will give you. See, my dear friends. Yeah, in two cases also we can solve. Which one in two cases, sir? AB. Which one in two cases? See, if you want, you can do it in 5 cases also. If you want, you can do it in ending with 1 as separate problem, ending with 3 as separate problem, ending with 5 as separate problem, ending with 7 as separate problem. 5 cases actually. But instead of doing all the 5, we'll do the same story now. So that's why that instead of doing 5 times, we write directly 5 here. That 5 will take care of that. Or. That is 5. That 5 will come like that. Am I clear? Achha, you are solving this one. 9,090. Okay. Akash Bandari, you given wonderful. Good. Now first let me give you a common sense solution for this. See, non-negative, some people get doubt. Non-negative integers means, see, positive integer starts from 1, 2, 3 and so on. Non-negative means which are not negative. 0 is neither negative nor positive. So starting from 0. This is what you are interested in. Now I'll ask you a question. How many non-negative integers less than 5 are there? How many non-negative integers less than 5? 5 is not included. Less than 5. 0, 1, 2, 3, 4. How many are there? 5 are there. So number of non-negative integers less than 5 are 5. Then number of non-negative integers less than 10 power 5 is how many, sir? 10 power 5. Common sense way of solving it. It is common sense. See, when you do counting, okay, as a computer science student, you should know common sense because interviews that is needed. Okay, you should know logical approach because we need to teach to some fellow who is dumb but who can work much faster than us. Am I clear? So one should always understand these ideas. As a computer student, Computer science student, you have more restrictions, my dear friend. A simple problem need to be seen in different ways also. Am I clear? Wonderful. Now, the logical way of solving it. As one of my friend done, that is also fine. He taken one digit number. Because 0 is also included, no? That should be, Akash, that should be 0 is also included, no? One digit number. Am I clear? One digit number, 10 possibilities. Because 0 is also allowed. Two digit number, in this, what happens? 9 into 10. 3 digit, that is wonderful idea, my dear friend. But 0 also included, that also you have to include for one digit number that you missed, my dear friends. Now let me tell you the most logical idea for this. Okay, that's a wonderful idea, Akash. I like that. Now look at this carefully. 10 power 5 means after 1, 5 zeros. After 1, 1, 2, 3, 4, 5 zeros. It is a 6 digit number. Now when you say less than 10 power 5, it is maximum 5 digit number. And it's not just 5 digit number. Okay, it is 5, 4, 3, 2, 1 digit number also. So when you say less than 10 power 5, the number which you get is a 5 digit number or 4 digit or 3 digit or 2 digit or 1 digit. That way you can solve it. But for 1 digit number, 0 is also included. That you should remember. See, that one way of solving is what our friend Akash done. That's wonderful, sir. Akash, that is correct. Perfect. No problem. Such small mistakes happens. No problem. Now, if you want to solve it at a time, maximum you get 5 digit number. 1, 2, 3, 4, 5 digit number. Okay. Now see this carefully. In 5 digit number, 0 is not allowed here. Without 0 here, you get 4 digit number. That is, if you take 9 choices for this, 9 choices, that is with 1, 2, 3, 4, 5, 6, 7, 8, 9, with 9 choices, here carefully, with 9 choices, we get 5 digit number. But if I include 0 also, there is 9 choices already done, no? 10th choice. If I include 0, that is if I put leading 0, it becomes 4 digit number also. I am also including 4 digit number. Am I clear? So this is the idea, my dear friends. Leading 0, including leading 0, okay? By allowing 0, leading zeros, we get 5 digit numbers, 4 digit number, 3 digit number, 2 digit number, 1 digit number at a time. So with 9 choices, I get 5 digit number. So I take 10th choice also. 10th choice for what? To get 4 digit number. Again here we have 10 choices. Again we are having 10 choices. Again we are having 10 choices. Again we are having 10 choices. So the answer would be 10 power 5. So the idea here is, this is called idea. Because an idea can change our life. What is it? By allowing leading zeros, we get 4 digit, 3 digit, 2 digit and 1 digit numbers also. So with this idea, at a time I solve this problem, my dear friends. I don't have to wait. Like, see, what Akash done is correct. That is not wrong. That requires, considering all 5 digit that much. Suppose if I give, suppose 10 power 5 again. If I say 10 power 100. With this directly I give the answer. But with this also I can answer directly, sir. 10 power 100 means after 100 zeros are there. Less than that means, okay, 99 digit number. 10 power 99 will be the answer. Am I clear? So after 100 digits. So less than that means 100 digit number. 10 power 100 you are going to get. 10 power 100 you are going to get. Is it clear? See, that is the idea, my dear friends. Because an idea can change your life, no? See, look here. Let us talk about 2 digit number. See, 2 digit number means with 9 choices and 10 choices. That is 90. 2-digit numbers are there. Now, 0 choice. If I allow 0 here, that is one choice. How many numbers are there, sir? 10 numbers are there. So 90 plus 10, I got 100 or not? So 9 plus 1, 10 choices followed by 10 choices will give me 100 answer. This is what we call it as a logical way of solving the problem. Am I clear? See, any other way is fine. This understanding is very, because leading zeros, if you don't put leading 0, you get 5 digit. If you are only interested in 5 digit, you don't put leading 0. But you are interested in 5. So with 9 choices, I get 5 digit number. With 10th choice, that is with 0, I get 4 digit number. Again, here also 0 possible, no? So 3 digit number, 2 digit, all are possible. That 10th choice will give me all possibilities, my dear friends. That is the trick in this problem, my dear friends. Hope you understand. So this is the logical way of solving this problem. Okay. Wonderful. And this is all normal. But you please try this as homework. Tomorrow I do P-Jan whole principle. If you remind me, tomorrow towards the end I solve this problem. If anyone reminds me this problem tomorrow, I'll solve this problem. This is homework. How many non-negative integers less than 10 power 5 contain the digit 1? Contains the digit 1. This is the question. If you want, you can answer that in the comment section, or tomorrow at 8 p.m. we are having same counting principle. This week entirely we are talking about counting principle. Actually, I thought of coming with C programming, but I will be coming little late. Mostly complete C programming or other ideas. But this week entirely we talk about basic counting technique. All the basic counting techniques, very logical way we continue, sir. It's not like just writing answers. This is not about, if you are only interested in answers, it is not for you. If you want to understand the logical way of solving it, this is the place for you, sir. For computer science student, this is how we should understand, because we need to teach it to someone else. Got it? Perfect. Try this tomorrow. You can write it in chat box or you can write it in comment section also, Akash sir. Okay? Tomorrow we discuss this question after P-Jan whole principle. Tomorrow we discuss P-Jan whole principle. One of the interesting problem, my dear friends. Am I clear? Tomorrow 8 p.m. If you have any other general doubts, we can discuss. Otherwise, we'll call it a day. Sampreet Kulkarni, please write your answer in comment sections. Let us see. Okay? You please mention this time slot and write the answer. Am I clear? That is not correct answer. Okay? Tomorrow we'll discuss that. Any general doubts you have, you can ask me. Otherwise, we'll call it a day, sir. Thank you. Thank you all. Any doubts? No, right? So we call it a day? No.